Hello, CocoaHeads. Do you have the energy for one more?
Yay!
Alright, one person does. Okay. So I'm Nevyn. I built this thing called Look Back. I'd like to try to do 3 things in 10 minutes. Just show you quickly what we've been up to at Look Back recently. Show you an interesting debug session relating to some of the private APIs we've been using. And then if there is any remaining time, just show you some completely unrelated open source code I've released recently. Right. So Look Back is this thing that was originally conceived as a UX research tool. It records the screen, the camera, touches, and so on. And the cool part is that it uploads all this to our really cool website, where you can then view these really nicely and share the link with your colleagues and so on. So since you last saw it, we had this new design by Max Goodbye, which you just bring up by shaking the device. I really love that animation. You can also get a list of your experiences and share them directly within the app. You can also put look back in your App Store apps. So like if you want to ask your users to share a bug report with you, they can record a short video of the bug for you. Right, so I loved working on this project because it's a developer tool for developers. I'm helping people who are like me. That's a lot of fun. Except for the App Store safe version of Look Back. It also means no App Store, which means private APIs. I just love me private APIs. The primary one I've been using is IO Surface. I love IO Surface. It's how different processes share video memory between them. It's a public API in Mac OS. It's pretty easy to figure out since you can look at the Mac and see how it should work on iOS. Behind the scenes, it's doing magic, but to you, you just get pixels for anything. So that's nice. However, there are many surfaces in a system. Every app has its own IO surface. They're in different formats, different purposes. So how the heck do you get your handle on one of these cool surfaces? I tried class dump. That's the #1 tool when you're reverse engineering on iOS. You just class dump something that you shouldn't, and you get stuff that you shouldn't, and you have a lot of fun with it. That didn't work too well on iPad, so I did some Googling. I'm not the only one who tried recording stuff on iOS. So I found this header called IO Mobile Frame Buffer. This is a private API. I think it's reversed engineered by Steve Troughton Smith, but I'm not sure. Someone did this, and it works. So I used it. Until a little while ago, when we got a report that it crashes on iPad Air. So that was unfortunate, and I couldn't reproduce it, and I figured maybe my application, my test application, which is just one view, I figured maybe it's just not as complex. It just crashes in really complex applications. Finally, I get a crash report, so I could investigate it more thoroughly, and when I see it, my heart sinks because it crashes in the private API usage, of course. So I've been bragging all this time about how I've conquered the Apple APIs. I've done what Apple didn't want me to do. I'm really awesome, and suddenly I'm just reduced to a script kiddie copying code off of Google, and I had no idea how to debug this. So there's no documentation, of course, no support forum. You can find an answer for this on Stack Overflow. I was just on my own, which is really rare nowadays. So after a while, I managed to get my hands on an actual crashing project, and I decided to human up. I'm not giving up. There would be a defeat that would crush my soul. If I gave up, I would be a script kid for the rest of my life. Not acceptable. So that's the function that's crashing. I figure I'll just try every variation of parameters. Maybe the sample code I found is using it wrong. Nope. Is it in the customer's app? I stripped down the customer's app to like a single source file, and it's still crashing. And it took me hours to realize maybe I should look at the build settings. So I do, and the slap on my forehead probably was heard all over Stockholm because I built my my project for 32-bit only for some stupid reason. So it's a 64-bit crash. All right, that was very stupid, but you know. So I started this prototype some more, and I was like, why is this crashing in 64-bit but not 32-bit? Have they changed how it works in 64-bit? They could do that because it's private API. They do whatever the hell they want. Maybe it's the int there. I did this talk at NS London, and everyone was laughing because they thought it was the int. It's not the int. I tried that. Finally, I realized I do have the source code for this. It just happens to be in assembler. Xcode disassembles code for any frame we can't find the source for. You've probably seen this before in your debugger. And you're like, normally when you see this, it's like, oh, it's gibberish, I'll just give up. But I had no choice. I had to dive in. And I don't really know assembler that well. There's this really cool tool called hexrace, which will decompile this into C. So it will look at the C and see what it should correspond to if it was C. Way too expensive, can't afford it. But come on, it's 7 lines. I should be able to do this. I have some basic some basic assembly knowledge. You can download the instruction set overview. This looks scary. It's not scary. You just go search for whatever instruction you're missing in it, and you'll see what you get to. So, okay, I'm going to do my first decompilation. What does that look like? So the code in green, that's the assembly. That's the stuff that's crashing. And so I need to figure out what the C is, and this is what I came up with for this very trivial function. So I just searched for CBZ is the instruction. Do I have a mouse cursor? No, it's right there. So what does that mean? Well, I looked it up. It's like compare and branch of 0, and it looks at x0, which is the first register, and that's where the first parameter to your function is going to be. So it's looking at the connection. It's looking, is this 0? If it's 0, we're going to jump to the end of the function and not do all this stuff. So it's a simple test for null. That's very simple to translate. And we'll look at the next one, LDR. It's like load address, maybe, something like that. It looks at x0 again and puts the result in x3. And what it's doing is a simple pointer dereference. So connection is probably some sort of pointer to a struct, and it's dereferencing 552 bytes into that struct. So we now know that connection needs to be a valid pointer. It's not just some random int. It needs to be a pointer. So why would that crash? Normally, if we crash when we dereference a pointer, it's normally because it's null or not valid memory. It can't be null because we're testing. That's the first thing we're doing. So it's probably a broken pointer. How can it be a broken pointer? I don't get it. But hold on, what is connection? That struct I have up there is just what I'm inferring. If we look at the code, it's typedef to an IO connect T. So like, okay, maybe that type is wrong. What's an IO connect T? An IO connect T is an IO object T. All right, so that makes sense. What's an object T? An object T is a MAC port T. All right. Starting to feel like a rabbit hole. A MAC port T then. Well, that's a Darwin MAC port T. Okay, fine. So what's the Darwin MAC port T? A Darwin MAC port T is a Darwin MAC port name T. And it's used by Mac, obviously. And that in turn is a Darwin natural T. And then, okay, what the heck is a Darwin natural T? That's a unsigned int. Finally, we reached the end. That's not a pointer. That's pointer sized in 32-bit. On 64-bit, ints are still 4 bytes, so you can't fit a pointer in it. So we have an invalid pointer. Our data size is wrong, which means that we're sending in a pointer and we're throwing away half of the pointer. That's a very invalid pointer. So that should crash, and it does. So we just change it to some pointer, I don't know. And that makes it work. It's no longer crashing. And that's it, really. I'm not sure what the lesson is. It's maybe use more private APIs. Those are fun. I don't think Apple wants me to say that, so I shouldn't. Maybe it's assembly isn't so scary. More likely it's our community is awesome, and people like Mike Ash, Greg Parker, and others who've written really awesome blog posts on related subjects have all taught me this stuff that gave me the courage to debug this really scary stuff. Thank you. Ooh, do I? Ooh, okay, 30 seconds. So, okay, this thing in Spotify for iPad, I have this stacked navigation thing. I copied it off of the old Twitter client. So I made this. I was very proud of it. I put a lot of work into this. So I wanted to open source it before my employment at Spotify ended. So I did. I had several days of margin. I should have released it like 2 years ago, but whatever. Now it's there. If you want to have something like that, it's now available. Literally 5 minutes before my employment ended, I managed to open source this one. This is from a Hack Day project that I really wished I had done something more serious with. So I'm really tired of context menus and non-direct interactions. I wanted to try what's drag and drop like on iPad. So I tried to put that into the Spotify app. That code doesn't compile anymore, so I can't show how cool it is. So this is just a trivial demo app, but some basic infrastructure for trying to do drag and drop on iPad. That's it for you.